He would have been like, okay, sure, you're good. Okay. The first thing we're going to answer today is what is a radian? Mr. Radian, who is he? Who is he? Does anyone know?
On a surface.
What?
It's a unit for measuring angles.
Yep, exactly.
Good job.
Now, what's special about it, though?
It's measured in
It's what?
The quarter of a circle.
Pi over 2 radians is a quarter of a circle.
Oh, isn't it? Okay.
Isn't it? Never mind.
It's okay if we don't remember.
A circle's 2 radians. Right? Or 2 pi 2 radians.
Yeah, there's 2 pi radians in a circle. Well, that's more of a side effect of the definition. So here's a question for you. If you were running around a track, a circular track, pay extra close attention to this. This is going to tell you what is a radian. What is a radian? Okay. So let's say the track had a radius of, let's just use a number like, say, 100 feet. Okay. If you traveled 1 degree around the track, so if you subtended 1 degree of the circle, how far would you have run? Who can do that in their head? If you can, you might be like a Rain Man type genius. So let's do 1 degree. So if we did 1 degree, because we all know what a degree is, right? A degree is a 360th of a circle. And that makes sense. Why 360? Well, if that number is highly divisible. So if you say, oh, let's just arbitrarily choose 360, that's a pretty good number to pick because you can chop the circle into halves, quarters, eighths, sixths, twelfths, 36ths, 24ths. Like the only numbers that don't go into 360 are like 7, 13 doesn't go in. But most numbers, let's say a lot of numbers go into it. So anyway, if you went 1 degree, what you do is you'd say, well, what's the circumference of the circle? 2 pi r, right? So you take the circumference of the circle, and then you would say, well, that would be a full 360, so I'd have to divide that by 360. That's not very pretty, is it? Let's see what that number is. I don't know. Oh, great, Mr. Quackmalator. How far is that? 2 pi times 100 divided by 360. You would have run about 1.745 feet. Okay, that's not very nice, is it? All right, now a biglier question. What if you instead ran 1 radian? This will answer the question, what is a radian? Who knows? Come on.
Would it be?
I'll give you a hint. 1 radian is about this much. I'm eyeballing it, but that's about a radian.
What degrees is that?
I don't know.
It looks like 60 degrees.
57 degrees. It's gonna sound like flat.
That's what radian is.
Oh.
Over your head?
Yep.
Okay, let's look at this. What does this mean? A radian, because you guys probably all know a radian is there's 2 pi of them in a circle. There's roughly 6.28 radians in every circle. Why do they choose that? They pick that. Well, it starts with this. A radian is the amount of circle you got to go so that you get this radius value as like your arc length. Okay?
Oh, gotcha.
So a more general picture would be like this. Any circle, okay, this is the radius. If you subtend 1 radian, that gets you an arc length of r, this length here, this curve. So this curve is the same distance, same length as that radius. Okay, that's what a radian is. That's what you got to start with. So how about this? What if I traveled What if I traveled 2 radians? How far would I travel? I would travel another. Let's go back to the 100. I like the number. I don't put the chair. It's in the way. Get out of the way, chair. Okay, let's travel 2 radians. So 1 more radian would get me another 100 feet. How about 3 radians?
One. Okay.
I've now gone another 100 feet, so I've gone 300 feet. How many radians is it to get halfway?
Like a radian, 9.110.
3.14159, right? So this is, now why is that? Why is this working out to be 2 pi? Well, we know the circumference of a circle, right? Ancient Greeks. We know that the full circle, this distance, is 2 times pi times 100. So the logic would be, if every radian is getting me 100 feet, then there must be 2 pi radians in the circle to get all the way around the circle, right? Does that make sense? So, and so the motivation for this, so why are we covering this in physics? That'd be one question. Because it gives a really nice relationship between the angle turned and the distance covered. Because the distance covered is just the radius multiplied by the number of radians. That makes sense? So generally speaking, if you have, this is getting a little ahead of ourselves here, it's the next problem, but if you've got a circle, okay, and you travel, let's call that theta, this angle, and this is the radius, let's call this arc length, L. For radians, this works out really nice. It's just the length is just the radius multiplied by the number of radians. Isn't that pretty? If you decided to use degrees, the formula would be disgusting. With degrees, it would be the arc length would have to be 2 pi r multiplied by the fraction out of a circle. Disgusting, right? Yes? No? Is this making sense or no? 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 Okay, well. Maybe this will help a little bit. Sad zombies. Okay, let's look at this. Let's fill in the chart. Guys are so sad today.
Mr. Hall, we could have been enjoying the fresh snow on the mountain.
Nothing stopped you from going.
My parents.
Your parents just told you no?
Yeah. I've seen so much.
Oh,
So upset that I have to be here right now. That's fair.
Bootstraps were not pulled.
No.
Sad.
Yeah. Oh,
I know.
What?
and Zach's up on the mountain and Colin, and like
Sam, Seth,
like half the class.
I think Stevie.
Niels, George.
Well, Stevie's team will have been powder left for the rest of us.
It's probably pretty good up there. I think yesterday was probably the day to be there.
Yeah, basketball
Yesterday
racing
afternoon
yesterday
was
was
probably the
epic.
best.
Haskell racing.
So, okay, let's look at a comparison here. So, for example, like on a circle, 1 full revolution. So 1 full revolution corresponds to how many radians?
2 pi.
2 pi.
Yeah.
So roughly 6. So there's only about 6 radians in a circle. Okay, and that corresponds to 360 degrees. Okay. And then while you're at it, you might say, well, this tells me that pi radians corresponds to 180 degrees. Or we could say, if you wanted to say, well, half a revolution, half a turn is pi radians or 180 degrees. Okay, so then think about 30 degrees then. Well, what's 30 degrees? Think about some ratios here. How does 30 compare to 180?
It's
It's a sixth, right? So how many radians is it?
one.
A sixth of pi. A sixth of pi, right? Makes sense? So here, I'll write it out. So 30 degrees, right, is a sixth of 180. So therefore, it corresponds to a sixth of pi radians. And then how much of a revolution is that? Well, a 12th, right? It's a sixth of half a revolution. So that would be 12th of a revolution, right? How about 45 degrees? Yeah, so you gotta go, oh, that's a quarter of 180. So that's a quarter of pi radians.
We did eighths of a revolution.
Yep, and that's a quarter of half a revolution, so it's an eighth of a revolution. Cool beans?
Cool beans.
How about 60 degrees?
Third.
It's a third of pi, right? And it's a sixth of a revolution. And then 90 degrees.
Half of pi.
Half a pi radians. And it's a quarter revolution.
Okay, that makes sense.
Oh, this is a big one.
Okay, now this next one is asking us to generalize. So if you have just 5 degrees, so if your number of degrees is just some number, what's the general relationship? Like, how do you get from, say, degrees to the number of radians? What are you multiplying by?
No idea. It doesn't
Okay.
in my head.
You're taking this. Look what happened here. Like, how do you get from pi, or sorry, how do you get from 180 to pi? You have to divide by 180 and multiply by pi. Right? Well, that's the ratio. No? Is this making any sense?
That makes sense.
Here's the formula. Let's ask ourselves if that makes sense. Is that what happened here? If you multiply 45 by pi over 180, do you get pi over 4?
Yes.
Write it out here. Or say 60. We did 60 earlier, right? 60, we went 60 times pi over 180. 60 goes into 180 3 times. So 60 degrees is pi over 3 radians.
Okay.
Liv. Feel good about that?
Yeah.
Okay, and then how many revolutions is that? So how do you go from, say, well, I mean, there's kind of a simple way to do it, right? How do you go from degrees, because remember, this is how many degrees you have, pi, to revolutions. Maybe this is the easier one to look at.
Wouldn't this be? At least my understanding is you just pretty much divide by 2.
That's how you go from radians to revolutions, because there's 2 pi radians in each revolution. So to go from radians to revolutions, you divide by 2 pi, right? But remember, this is a number of degrees. So how do you go from, let's say, okay, Tony Hawk did a 900. Think about that. What's a 900?
That's
Wait, that's
That's like 360.
There's 360. There's 2 360s. That's 720, and then one more 180. So he did 2.5 spins. You divide by 360. Yes.
Yes.
Is that what you were saying? So the answer is, if you have this many degrees, like how do we go from 30 to 112? Well, you could think of that as dividing by 360.
Okay.
You sure that makes sense?
Let's see.
What's wrong, Julia?
Nothing, it makes total, complete sense.
What troubles you, young Padawan? You guys are triggering me so bad.
We should all just stare out the window the rest of the class and just contemplate our life choices.
Stare at the wall.
And just die on.
You know. Should have been a snow day.
Should have been.
Should have been.
We can make it snow day, I think we should march out of the school and enough people don't show.
I'm not like, honestly, I obviously would, I mean, almost any day I'd rather out be outside doing something, but
Can't see for those 6th graders to be somehow.
Snow walkout.
well, they got 3 inches. It's not like,
Oh, they only got, how many did they get?
they got 7 in the last 24 hours, but the other, everything got tracked out yesterday. I'm sure yesterday was like packed, so I mean, I'm sure it's a good day to stuff these, but it's not like they got like 10 inches overnight. Then I'd be really kicking myself.
What's their 3-day total?
I don't know if they even posted that.
I don't know if they did 3 days, I was 7 days, but I don't know if they did 3 days.
17 inches in 7 days. They had 7 inches in the last 24 hours, and then, so yeah, I'm sure it's good. But
You were to hike up to the radio towers,
Oh, yeah.
that's what I'm doing tomorrow.
be careful.
I see the trees in the gray wolf, it's not terrible.
Okay, let's finish this here. So hopefully now you're comfortable with going, if you know how many degrees there are, you can transfer those degrees and convert that to radians or revolutions. Now let's go the other way. 1 revolution. Okay, 1 revolution, this is already written out for us. 1 revolution is 2 pi radians, and that's 360 degrees. Okay? This one's actually really easy, because then you go, what about 5 revolutions? How many radians is that?
10
10 pi. How many degrees is that? 1800. 360 times 5. Just multiply by 5. How about 20? So you can see you're just multiplying it all by how many revolutions you got. Okay, so that's probably the easiest of the 3, is going from revolutions to everything else, because if you have R revolutions, so this is how many revolutions you know. Oh, that disk spun 1,000 times. Okay, well, all you would do is multiply your number of revolutions by 2 pi, because there's 2 pi radians in each of those revolutions. Okay, and then there's 360 degrees in each of those revolutions, so you multiply the number of revolutions by 360 to get how many degrees you went. Right, Kate? Okay.
You can do the 30. Can you do 150 times 260? I can't do that.
I gotta practice that. You're gonna hit a little jump there, Mr. Hall.
150.
What movie is this where they do this? Oompa Loompas.
Oh!
Charlie and the Chocolate Factory.
What is it, Caleb?
I don't know, Winslow didn't take the news guy.
It's like 540 with an extra 0, right?
Yeah.
Because 1.5 spins is a 540, so times 15 would be like, yeah, Just hit them with a bruh and then a yeah. That's all you gotta do.
Yeah, it's
Yes.
5.
So 150, and then add another zero to that.
Wait, what?
54,000.
Yeah, 54,000.
Yeah, right, Henry? Henry knows. Henry's a sad movie. Oh no, my camera. No. Please no. What?
I couldn't spell the last name Schumer this morning. It's been one of those days.
Oh, I also, here's another funny one for you, Caleb. It's not exactly like not turning your Chromebook light off, but
Yeah.
another moment of weakness, I looked at Boomer Book for like 2 minutes this morning, and this person was commenting, and they wanted to use the phrase cognitive dissonance and like butchered the spelling, but then followed it with this long parenthetical sentence about how they have trouble spelling. Why don't you just type it into Google and look at how it's spelled? Why did you have to like add this qualifier of how like, hey, sorry, I think I probably misspelled cognitive dissonance back there. Just want you to know that I have trouble with spelling, and sometimes,
Use the text to speech.
well, I know, I'm like, you literally could type into Google like the worst spelling of that phrase, and it would come up for you. So
Yeah. Jeez, some people.
anyway,
Wearing
it's weird.
jeans and tennis shoes to go snowshoeing.
Well, it's like people will go on like Reddit and like reply to a post and just ask like, "What is that?" And it's like, "Have you ever heard of Google?" You can type the thing you're wondering about into Google. They'll literally ask questions like, "Oh, what? Yeah, what is cognitive dissonance?" Like you can just type it into Google and it'll explain it to you.
Maybe people are just craving some human-to-human interaction.
That is a very charitable interpretation. I like that, Julia. That's what I need to do with my mind.
She's thinking positively. Mr. Hall, you're
Yes.
thinking very negatively.
That's true. That's true. Okay. So,
Did we all-
Last one. what?
We've not solved that puzzle.
I didn't know if they were solved.
I'm not going to spoil it. Okay, these are all radian values. So let's see if you had pi radians. This one's pretty easy. We've already done this one, right? So pi radians is 180 degrees, and that is half a revolution. Oh, this one hopefully is obvious. 360 in a full revolution. So 15 pi.
Just,
I think it's easiest to go to here. Would you agree?
yeah.
Because think of 15 pi. I mean, how many spins is that? 7.5 spins. So 15 pi would be 7.5 revolutions. And then how many degrees is that? You got is that right? You got to multiply it by 360.
Yeah.
That comes out to be 2,700.
Someone clarify that one.
Yeah. So that times.
Let's see what's going on.
That times 360 gives you.
2700.
Yeah, it's.
Thank you for confirming.
7-0.
Okay. 50 pi, same thing. Divide that by 2 pi to get, that's 25 revolutions, which tells us over down at the bottom, you get 9,000.
Think about doing that many rotations like on skis.
I could do that.
You can do that if you're tomahawk.
Only when no one's watching.
Uh,
Okay, so with theta, so if you're given some general number of radians, okay, how do you get from here to say the revolutions? You simply divide your number of radians by 2 pi, because there are 2 pi radians in each revolution, and then to get the degrees, you're going to multiply that by 360, which if you think about it is the same as saying take theta and multiply by 180 over pi. By the way, that's the reciprocal of the other one, right? To go from degrees to radians, we multiply by pi over 180. So to reverse that, we multiply by the reciprocal, 180 over pi. Isn't that neato burrito? Mosquito? Yep.
fascinating.
Trenton knows. He knows.
Oh, boy.
All right, let's do the arc length table. And the twisty. Were you guys like this when it was sunny? That
I was
Wednesday?
so happy when it was sunny. I was
weren't you upset to have to be trapped inside?
Oh yeah, I was.
Well, I went skiing after school, so.
I would peel logs and I was like peeling logs with a smile on my face. It was awesome.
There you go. Peeling logs. Okay, so as we covered a few minutes ago at the beginning of class, this is the whole reason that radians are like relevant, is because it allows you to make this really nice relationship between how far you rotated and how far you traveled. So again, this is r. If this is theta, then this arc length would be r multiplied by theta. So again, I can't stress this enough. This is the whole reason radians even exist. Okay. They were like, oh, if we define our angle measures in this kind of funky way, we can get this really elegant, simple relationship between rotation and distance. So, for example, a 5 meter radius that rotates 10 pi radians, what's the arc length?
53 point something.
50 pi.
55.
50 pi, which is roughly 150 something, right? And the pi is roughly 3.
Didn't think that.
We could just write 55 then. Like,
Yeah, 50 pi is fine. 50 pi meters. So now 3 centimeters
3 centimeters.
going 180 degrees, that's a half rotation. Just think about 180. How many radians is 180 degrees? Pi. So the distance is 3 pi.
Wow.
Which you could have also figured out another way. You could have gone, oh, the circumference is 6 pi, so half of that's 3 pi. The next,
Doesn't matter whether that's in centimeters or not.
the third row is just going to be r times theta. That's the formula.
Mhm.
All right, so then how do you go the other way?
Mhm.
Let's say you know the arc length, right?
5 by theta.
Yep. So if r times theta gives you your arc length, then if you want to reverse that, say you want to know the radius, okay, well this means that the radius is the arc length divided by the theta. Or you could also say that theta could be found by dividing the length by the radius. By the way, that's an interesting way to define what the radius actually means. The simplest way to define the radius is what's the distance from the center to every point of the circle. But this, you can think of the radius as being how many meters are there per radian of travel. So if the radius is 6, that means you're getting 6 meters per radian of travel. So anyway, what's no yawning.
All right.
So so this next row would be 25. 25 what?
Wait, what?
25 kilometers.
25 kilometers. Right?
Yeah.
How about the next one?
25 centimeters.
Let's see the next one. So it's so this next column would be, you have r is your radius, r times pi over 2 somehow got you 40. So multiply both sides by 2 and then divide by pi. And so it turns out the radius must have been this weird number, 80 over pi. And don't be afraid of the number. That's just roughly, I don't know, what is that, like 25-ish, 26-ish? Something like some decimal. Okay. For the next one, it's just going to be x divided by theta, right? Ooh, the next row is very beautiful, very aesthetic. This can go on your Visco. A 1 meter radius to get a 1 meter arc length needs to rotate 1 radian. 1, 1, 1. Isn't that nice? Julia, confess, it is nice. It is nice, you must admit. Okay, 2 meters. And by the way, if you've only taken like algebra, trig, pre-calculus or something, then you pretty much have exclusively dealt with like multiples of pi or fractions of pi. There's nothing stopping you from having, like in this next one, how many radians do you have to rotate to get a 2 meter radius to travel 30 meters on a 2 meter radius circle? 15 radians. Does that make sense what I'm talking about? Like when you do the unit circle, it's all like, the unit circle is like, oh, you got pi over 6, you got pi over 4, you got pi over 3, right? And so on and so forth. But do they ever talk about 1 radian or 2 radians? Not very often. If they do, it's probably an afterthought. Where is 1 radian on there? Roughly.
Pi over 3.
It's pretty close to that. Because pi divided by 3 is roughly what? 1 point. Let's see. I'm curious. It's 1.047. So 1 radian is just barely shy of pi over 3 radians. Like you said earlier, 60 degrees. We definitely want to know how many degrees is 1 radian? We are dying to know, right? How do we calculate that? Well, we made a formula earlier, right? It's the, on our first page, it was the, how to go from radians to degrees. The formula was to multiply by 180 over pi, right?
Yes.
It's the last row. So 1 radian multiplied by, there's 180 degrees per radian gives me, 180 degrees per pi radian. Sorry about that. The anticipation. 57.296 and a whole bunch more stuff. Degrees. Yada, 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 exactly. Okay, man. End the stream. This class is brutal today. It's the worst day of my life. Just kidding.